Hello, welcome to grade 11 college math. We're in unit 6 on statistics, and we're doing lesson 3.4 on measures of central tendency. More specifically and more importantly, this involves calculating the mean, median, and mode of data sets. So perhaps the most important and useful lesson out of this whole unit is calculating these three tendencies, or these three calculations: the mean, the median, and the mode, and clearly understanding what the difference between each of them are. So here are the scenarios where we'll figure out how to do each one. Okay, so all right, measure of central tendencies: the mean, the median, and the mode. Two car salesmen are competing for a mid-year bonus in their pay. The owner of the dealership wants to assess the better competitor. Who is the better candidate? So here's Matt and Jordan, and how many sales they made that month, or those 6 months. Matt made 16, then 28, then 32, then 28, then 26, then 31. Jordan made 34, 30, 26, 26, 27, 26. So I'm fine. I find it hard to just eyeball this to tell whose average is greater. So it will be better to do the math. So let's check their averages. So in Matt's case, okay, so Matt's average. Sorry, messy there. Okay, what do we do here? So what we do is we take all his values, and we divide them. We add them all up, and we divide by the number that there are. There's 6 of them. And so we can do this on our calculators. All right. So 16 plus 28 plus 32 plus 28 plus 26 plus 31 is 161 divided by 6 is 26.8 sales per month. Okay, now we'll take Jordan's average. So he had 34 plus 30 plus 26 plus 26 plus 27 plus 26, all divided by 6. So let's punch those in. 34 plus 30 plus 26 plus 26 plus 27 plus 26 equals 169, sorry. Divided by 6 is going to be higher at 28.2 sales per month. Okay, so what can we say then? It appears that Jordan sells more cars, but why is Matt's first value. Sometimes you come up with questions. Why is his first month so low? Right? So there's some things that stand out. Like, why does this stand out so much? Is there an explanation? So as an employer who gives out bonuses, you might want to inquire, like, oh, then we realized Matt was sick for a week that week or something like that. Anyways, maybe he was sick that week. Should he be penalized for that? Not necessarily, right? So he was sick, or maybe he had the birth of his first child and he took time off, or maybe he was on holiday. Okay. Sorry for the messy writing, but all right. So that's average. We've known how to do averages for a while in school. We've done them before. All right. Now it says, what about checking the middle values? Well, we had 6 values of each. So if we were to list the middle values, okay, reorder them. So for Matt, if we were to put them in order, we have 16 is the first one. The next lowest is 26. The next lowest is 28 and another 28, so 28, 28, and 31 and 32 are the last ones. Okay, so let's take Jordan's now. So his lowest was the 26s, and he's got 3 26s in a row. And then he has a 27, so check those off. He's got 27. And he's got a 30. Am I missing? Oh, I'm missing a 30. Don't put the 34 yet. So 30 and 34. So it asks for the middle terms. Now we're dealing with a even number, right? So the middle terms in this case are these two and these two. In this case, it's pretty clear. 28 is the middle value. Okay, now in this case, we have to do an average. 26 plus 27 divided by 2. So that would be 26 and a half is the middle value. So you could make an argument that actually his middle value is 28 and his is 26. So Matt did a better job, where there's probably some higher numbers that we can look at. So what do we say here? We could say now it seems Matt sells more cars. All right, good. All right, check the consistency. All right, so what was that means we're going to see if there's some similar frequencies. So in other words, what happens, which numbers happen more often? So in Matt's case, okay, let's do green for Matt again. Okay, so in Matt, 28 occurs twice. Okay, and for Jordan, he actually has 26 comes up 3 times. All right, so what can we come up with for this reasoning? Is this important? Well, it would appear pretty messy. It would appear that Jordan is more likely to sell about 26 cars. Again, sorry about all the pen's acting a little bit glitchy here. So, as an employer, we could say, okay, if you just go on the averages, Jordan sells more. If you went and said, well, on a consistent basis in the middle, his best values are around 28, his are around 26, so maybe Matt's more consistent. Then you could say, well, if you like consistency, then and it's reliable, well, maybe you like the fact that Jordan can hit 26 cars more frequently, and that's a measure of consistency. Would be something you would want as an owner of the car dealership. So then you're left with the question: well, who do you think should get the bonus? Well, who do you think should get the bonus? Well, there's actually no answer to this. It's really comes to your opinion, what you're looking for in an employee, and obviously we picked an example where they're pretty close. But without coming up with actual terms, we did 3 things here. We checked just the general average, we picked the middle point, and we picked the most consistent. And for lack of, there's actually words for this. So the averages is going to be the mean, the middle point is the median, and the most consistent or most frequent number is the mode. And that's our 3 central tendencies. So let's give a definition to these, all right? There are 3 ways to define a common trend or a central tendency for a set of data. So what is the mean? Well, a mean, we use this squiggly M as a symbol, and it is the actual average. Okay, so the mean is, for lack of a better word, is the average. It is the sum of values in a list divided by the number of those values. So let's say you had 10 tests, and you could take your 10 marks, add them all up, divide by 10, and you could come up with an average. That would be a simple way of coming up with marks, let's say. But here's another example. So here we have this person in example 1. Jasara is buying a home that will require a mortgage. The bank wants to know her monthly salary. She works on commission, so she must calculate her average salary. Given her income for the first 6 months of the year, what is her average salary? So we will check the mean. And so we are going to add up all of these. 3675 plus 4,250 plus 3,225 plus 2,985 plus 3,650 plus 4,600. All divided by how many? 6. 6 months. Okay. So what will these be? Okay, let's add all these up. 3675 plus 4250 plus 3. Oh, I messed it up already. Anyways, you add them all up and you get 22385 divided by 6, and you divide that and you get in dollars 3,730 and 83 cents. Okay, so we can say that she will tell the bank her average salary, or her mean, is 3,730.83 per month. Okay, so that's a straightforward. I tend to think that the mean or the average is the most useful, in my opinion, for many, many reasons. I like using the mean. In lots of aspects of life. So I think that now the more values you get, the stronger your averaging is. If you just average 3 things and they're really distant apart, then that's less reliable. If you have an average of 100 values, that's that's a very strong average because you have so many values. All right, now we move on. So that was mean. And sometimes we get mean and median confused. So mean is the average, and median is different. It is the middle value when the data set is ordered from least to greatest. You have to reorder them. like we did in our first example. Okay, or else it just doesn't work. So to find the median, if there is an odd number of data points, it's easier. It's actually easier. So it's easier because you just take the middle one. So example, if there are 13 numbers, in the list, the median is the 7th value. Right? Because think about 13. So 13 is one beyond 12. So 12 would be 6 and 6. So the 7th is the in between, the middle value. All right, next. What if there is an even number? Well, you're going to have to average it. So then the median is the average of the two middle numbers. So add and then divide by 2. So let's try these both out. So we're going to find the median. We have to reorder first, okay? So find the median mark for each of the student grades. First, list the numbers in ascending order. Ascending means smallest to largest. All right. So in sample A, we got to look at which are the smallest. So here we have 54. Next would be 62. Next would be 64. Next would be 72. 76. Boy, this person's all over the map here with their marks. But anyways, 89 and 93. Okay, well, if we go 1, 2, 3, 4, 5, 6, 7, we have 3 and 3 on this side. So here's our median. Okay, the median equals the 4th entry equals 72. Okay, let's try the next one. Listing these in order. We have the lowest is 56. Next is 62, 63, 67, 84, and 98. 84 and 98. Okay, so in this case, we have 1, 2, 3, 4, 5, 6. So here are the middle 2. Okay, so the middle 2. All right, and we're going to have to average them. So the median, in this case, equals the average of the 3rd and 4th numbers. So we are going to have 63 plus 67 divided by 2. And so that ends up being 65. Okay, so that's the way we do that. And that is called the median. The median. So think middle. Median sounds a little bit like middle. So median is going to be your middle number that comes up. All right. What is our mode? Mode's a little different. Sometimes it's really useful. Sometimes it's not as useful. But basically, mode is the value that occurs most frequently, most often. Most often. There can be no modes. There can be no modes. Like if they all show, if every number is unique and there's always only one set of every number, as well as it can be more than one mode. Again, another reason why it's not always as helpful. So here's our example. All right, so looking at this first data set, find the modes for each of the. So do we see any repeating? 5, 7, 9, 8, 6. No, none of these repeat. So there is no mode. Each number is unique. Let's try this next one. So we have a 25 and a 25. We also have a 30 and a 30. And then there's no match for the 32s or the 29s or the 20s. So there are two modes. $25 and 30. So that's possible. They're equal. There's two of each, two 25s and two 30s. So that's why we say there's two modes. Now let's look at this one. So do we have any other 63s? No, you kind of have to look it through. Actually, there are other 63s. Okay, but there's two of them. 57s, are there any other 57s? No. 66s, no other 66s. Any other 83s? 83s, no. 79, yeah, there's another 79 and another 79. So there's a good candidate. Is there any other 72s? And now that we know there's at least three 79s, then now 63 is no longer an option. Is there any 69? No. No other 69. And any other 60s? No. Any other 85s? No. Any other 80s? No. So it looks like by eliminating, we have come up with our mode. There is one mode, and it's 79. Okay, so that's how we figure out mode. All right. I have another example here. One last example, then we have another note sheet here. So it says, the modes of the following set of data are 9 and 7, or 7 and 9. What must be the value for y? Okay, well, if we're given this information, then we know that 9 and 9, there's two 9s. So there's two 9s. There has to be two 7s. So the y must be a 7. So that we match two 7s. anyways, that nothing more about that. But so we could say something like this. We could say since 7 and 9 are both modes, they must occur an equal number of times. So 9 occurs twice, therefore 7 occurs once, therefore y must be 7. All right, very good. So we have one other summary page for mean, median, and mode, and then a quick little activity we can try together. Maybe you try it ahead of me, but here we go. So mean. How do you choose which measures of central tendency to use? Well, here's a nice summary to help you out. When should we use mean or the average? Use when the data is fairly close together. Because if we have a goal scorer every year, and one year he scores 3 goals, the next year he scores 35 goals, the next year he scores 2 goals, the next year he scores, 40 goals. Well, those numbers are way too far apart. So to say his average then is somewhere around 15 goals, he's never once gotten 15. So it's a little bit inconsistent. So when the numbers are clustered nice and close together, then making an average makes a lot more sense. When is it good to use median? Well, it's useful when there are an outlier. Now, an outlier is a number that doesn't fit the trend. So it could be an extreme value that is so far away from the other values, which would skew the data. So it's like when we have a graph and there's one dot that just doesn't follow the rest of the scatter plot, right? So if you had a scatter plot like this, you had dots all the way around, but then you had one dot over here, right? You could say this is the outlier. And if you averaged it, then that outlier would pull all your average a little closer that way. And so it would skew it. That's what a skew is. So you almost want to just factor that out. So a median will pick the middle terms and kind of get rid of that outlier. Now, when is a mode useful? Good when the value of the data is the most important information. So it shows where there's consistency. And it is the only choice when you're talking about categorical. Remember when categorical was choosing like distinct things like your favorite type of ice cream, your favorite sport, where really you really want to know which one was the most. The only other time I would also say that the mean is good is when you have lots of data. You have so you just have so many numbers that averaging becomes stronger when you have so many values. All right, so let's just give this a try. This next activity, matching one of these to each one. When should we use? So identify whether each statement below describes a mean, median, or mode. Answers are not unique. A statement could describe more than one measure. So we might use more than one for some of these. Let's say usually the least representative of a set of data. So which ones use the least amount? Definitely mode. It's kind of more rare. What's the most popular? Well, I even said it for myself. I like to use the mean. People use averages way more often. May have more than one answer. Well, remember the mode we group the most often. Sometimes we have we're looking for 3 or 4 of those numbers popping up that are the same. Useful when comparing sets of data. Well, if we have large sets of data, we said mean was good. But again, if we have large sets of data, the median is also good. Not as popular as mean. Well, this is kind of, we just said mean was the most popular, so the other two are median and mode. Kind of a little bit redundant there. Extreme values like outliers do not affect it as strongly. Okay, so we said that. So if we're worried about outliers skewing our average, we could avoid average by going with the median in this case. Okay, what if we use for categories like type of ice cream flavors, your favorite type? Then we said the most frequent one will stand out as the mode. Only use one answer. We only use one answer. Well, yeah, because mode could be several answers. So mean is one answer. Median is one answer. Data must be listed in ascending order if done manually. All right, so remember we had to reorder the median to make sure we picked the one that was in the middle. It actually helps to reorder your mode because when you reorder the mode, you'll see them match up together. We didn't do that in our example, but I would certainly recommend you do that. Actually, I think it would be to your benefit if you did that. Now, it's difficult to interpret or compare if there is more than one answer. Definitely the mode, because like in our example here, these two modes are kind of, wait, they're down here. These two are kind of far apart, 25 and 30. They're not really that close together. So it's hard to make a comparison out of this, like how that's significant or how that's helpful. So that's one drawback to the mode. Not as popular as median. Again, I don't know why I keep coming back to this popularity contest here. What is affected by extreme values? So what could be skewed by an outlier? The mean, the average, right? The mean could just skew it a little bit, right? What is not affected by extreme outliers? Well, the mode is not, because you're looking for the most consistent. And what's useless if no values repeat? If we have no repeat values, we'll have no mode at all, right? So anyway, that's just a quick little activity to get you thinking about these. And that's the end of this note. So again, I can't emphasize enough that this is a very important topic to this unit, knowing these 3 central tendencies and how to calculate them. All right, so thank you for sticking with this longer note, and we'll see you next time.